Alright, let's look at absolute value equations now. You remember about absolute value, you studied that back in your middle school days. The absolute value of a number equaling 4 means that that number has to be either 4 or negative 4, which implies that the absolute value of a number is the distance that number is from 0 on the number line. Notice here, 4 is 4 units to the right, negative 4, 4 units to the left, but the distance is 4. So you can kind of think of absolute value like distance. It's not going to be negative. It's going to be greater than or equal to 0. In fact, the most typical definition of the absolute value of x is that it's equal to itself if x is greater than or equal to 0, but it's equal to its opposite if x is less than 0. So the absolute value of 4 is 4, the absolute value of negative 4 is 4. These are some useful facts involving absolute value. We're going to use them when we solve equations. It says let k represent a positive real number. The absolute value of x equals k implies that x is equal to k, or the opposite of k. Sometimes we just write plus or minus k. If the absolute value of something is equal to 0, that means that something, x, has to be 0. And the absolute value of x equaling a negative number implies there is going to be a solution. And if we have two absolute values equal to one another, that means they're either equal to themselves, x is equal to y, or they're equal to the opposites of one another, x is equal to the opposite of y. And I'll use this as I work out these examples. To solve the first one, I have one absolute value. I'm going to isolate it. And to do that, I'm going to get rid of the 5 that is times it by dividing by 5. So I'm going to divide both sides by 5. I have the absolute value of 2 minus 4y is equal to 10. Now make sure that your absolute value signs are big enough so that you don't think it's a 1 accidentally. Now, according to what I just spoke about here, if the absolute value is equal to k, in this case 10, that means the stuff inside the absolute values is either equal to 10 or its opposite. So that means that 2 minus 4y is equal to 10, or 2 minus 4y is equal to negative 10. Now I have two linear equations, no absolute value sign. I'm going to subtract 2 from both sides. I get negative 4y is equal to 8. And I'll finish this one off by dividing by negative 4. And I have y is equal to negative 2. Just had enough room here. Over here I'll subtract 2 from both sides. I have negative 4 is equal to negative 12. Divide through by negative 4. And I have y is equal to a positive 3. So I have these two answers, or as we sometimes write solution sets, they would include negative 2, positive 3. And with any equation, my suggestion is that you should probably plug it back into the original to make sure that it works out okay. Well, I didn't do myself any favor here. I'll put my solution set over here, negative 2 and positive 3, only because I didn't leave myself enough space to work the next example with this here. All right. The absolute value being on the right side is not a big deal. I can still solve this equation if you want, flip-flop the sides. That's the symmetric property of equality. If A equals B, then B equals A. So in this case, I'm going to undo the stuff around my absolute value to isolate it, kind of like I did here. I divide it, but here I'll have to subtract. So I'm going to have 5 minus 9, to get rid of the plus 9 there, is equal to the absolute value of 6x minus 7 plus 9 minus 9. So I have, and I'll flip-flop the sides, the absolute value of 6x minus 7 is equal to negative 4. Well, let's go back over here. If it's equal to a negative number, there's no solution. So this is a simple one. I don't have to go any further. My solution set is the empty set. Now for C here, I have absolute value of an expression equal to an absolute value of another expression. Well, according to property 4 there, that means that 3x minus 4 is equal to 2x plus 1, or 3x minus 4 is equal to the opposite of the quantity 2x plus 1. So here I'm going to get the variable on one side. I'm going to subtract 2x from both sides. Hopefully you can still read this. And that would give me x minus 4, combining like terms, is equal to 1. And then I will add 4 to both sides. And it looks like I have one answer of 5. Now over here, I'm taking the opposite of that. Remember, that's like a negative 1 that you're distributing by. And I have 3x minus 4 is equal to the negative 2x minus 1. I will add 2x this time. 3x minus 4 plus 2x is equal to negative 2x minus 1 plus 2x. I have 5x minus 4 is equal to negative 1, combining like terms. I'm going to add 4 to both sides to isolate my variable. At least get a little closer isolating my variable, and I have 5x is equal to positive 3, and then I finish this off by dividing by 5, and I have x is equal to 3/5. So I have two answers, here and here. For convenience sake, I'll go ahead and write it as a solution set. Alright? Pretty straightforward, kind of typical of what you'll see. This is a special case here. I have the absolute value of 4 plus x is equal to the absolute value of negative 4 minus 2x. The reason I say that this is a special case is that the stuff that's inside, these are opposites. Well, because I'm taking the absolute value of opposites are going to be equal. So this is going to be true no matter what number I plug in. Now you might not notice that at first. You may go through the steps like I did over here, but this is going to be all real numbers. Now I'll go through the steps really quickly. This is going to give me 4 plus x is equal to the opposite of x minus, negative 4 minus x. Or here I'm going to have 4 plus x is equal to the opposite of that, which should be written this way. So here I'm going to add x to both sides. And I have 2x plus 4, kind of changing the order around a little bit. I'm going to subtract 4 from both sides. And I have 2x is equal to negative 8, and then I'm going to divide through by 2. And I have x is equal to negative 4, and it's starting to look like, no, you're going to have one or two answers, as in the last example. But look right here. 4 plus x is equal to 4 plus x. So if I subtract x from both sides, you see I get a true statement. This is an identity. This is all real numbers. All real numbers. So you say, okay, well, what's your answer? Is it the negative 4? Is it all real numbers? Well, negative 4 is a real number, but it is the union of these two. It's the answers here and the answers here combined. So since that's part of this set, my answer would be any real number, and I would write my solution set in interval notation, just as I did above. And there we go. That's kind of a special case. All right, now we'll look at radical equations. Radical equations, the definition, an equation with one or more radicals containing a variable. The trick to solving a radical equation, of course, is to get rid of the radical. And to do that, we have to isolate it. Because once we have it isolated, then we can get rid of the radical by raising both sides to the power based on whatever the index is. If we're taking a square root, then we'll square both sides. If we have a cube root, we'll cube both sides, and so on. And in some cases, there may be more than one radical in the original problem, and after we isolate one of the radicals and square both sides, or cube both sides, we may have another radical left in the problem. And in that case, then we'll have to just do this step all over again. And just like with rational equations, if we have radical equations, after we get our answers, we want to double check to make sure that our answers are good and see if we have any extraneous solutions or extraneous roots. So I have a couple of examples that are pretty typical. Now they're both involve square roots, but we can do this whether they're cube roots or fourth roots by raising to the appropriate power, again based on the index. Now in this first one, the radical is isolated, which is really, really nice. I am going, because it's a square root, I am going to square both sides here. This would give me the square root of x plus 7 squared. And then on the right side, I don't square each individual term, I square the whole side, x minus 5 quantity squared. When you square the square root, you're going to get the index of x plus 7. And then over here, I'm squaring a binomial, x squared minus 10x plus 25. This is a quadratic equation. I'm going to get it into standard form. I'm going to subtract x and 7 from both sides. And that will give me 0 is equal to x squared minus 11x plus 18. And if I'm lucky, then this will factor. And this one does look like it's going to factor. I'm going to flip the sides. This is going to be x minus 9 times the quantity x minus 2 is equal to 0. I'm going to set x minus 9 equal to 0. I'm going to set x minus 2 equal to 0. Remember, that's called the property, the zero product property. I'm going to solve for x now. I'm going to add 9 to both sides. I have x equals 9. I'm going to add 2 to both sides. And I have x is equal to 2. So my answers appear to be 9 and 2. If I go back to this problem here and I plug 9 in for x, I have, let's see, the square root, this is a check. I have the square root of 9 plus 7 is equal to 9 minus 5. The square root of 16 is equal to 4. I get 4 equals 4. This answer looks pretty good. Now if I plug the 2 in, I have the square root of 2 plus 7 is equal to 2 minus 5. This is the square root of 9 equals negative 3. And no, the principal square root of 9 does not equal negative 3. It equals positive 3. So I have an extraneous solution. So my answer is just x equals 9, or the solution set with just the 9. Over here on the right, I have an equation that has two radicals in them, both square roots. And one of the radicals is isolated. You'd have to have at least, if you have two with an extra term, you have to have at least one of the radicals by itself. So I'm going to square both sides, just like I did in the last problem. A little more complicated to square it on the left. And by squaring this, it's kind of like squaring a binomial. First term squared, plus double the product, plus the last term squared. Over here, I'm squaring the square root of 3n plus 1 gives me 3n plus 1. So now that has 2 square roots of n plus 4 plus n plus 5 equals 3n plus 1. I have a radical, I have to isolate it, so I'm going to get rid of the plus n and the plus 5 first by subtracting n and subtracting 5 from both sides. Subtracting n and subtracting 5. And I have 2, the square root of n plus 4 is equal to 2n minus 4. I'm going to get rid of the 2 that's times the radical by dividing by 2. Now, I'm dividing both sides by 2 for a couple of reasons. I want to get rid of the 2, and I can also see that it's going to divide into it evenly. I don't have to do this. I can go ahead and square both sides now, but I think it'll just make it a little bit more convenient. If I was going to get some messy fractions by dividing through by whatever this factor is, I'd probably just go ahead and square both sides at this step right here. But I'll go ahead and divide both sides by 2. This should really simplify it, I hope. And that would give me, looks like n minus 2. Well, one more step of squaring both sides. I hope I have given myself enough room. Let's see, square both sides. And I have n plus 4 is equal to n squared minus 4n plus 4. Careful squaring the binomial. I am going to subtract an n and a 4 from both sides to put it into standard form. Subtract an n, subtract a 4. And I end up with 0 equals n squared minus 5n. I can factor out an n, flip the sides, so that gives me n is equal to 0 or n minus 5 equals 0. Now that one's already solved, but here I'd have to, hopefully you can still see this, add 5 to both sides, and I have n is equal to positive 5. So it looks like I have two pretty good answers. But just like I did back here, I'm going to check. I didn't leave myself much room, but I'm going to check and plug back in all the way back to the original. And you can probably do this in your head because the numbers are fairly simple. I'm going to try to write them down if I have enough space here for the check. So I'll plug 0 in first. I have 1 plus the square root of 0 plus 4. Does that equal the square root of 3 times 0 plus 1? Well, let's see, that's 1 plus the 0 plus 4 is 4, so that's going to be 2. Over here, that's going to be 1, the square root of 1. So, not looking good here. 3 doesn't equal 1. So this doesn't appear to be a good answer. Let me try the 5. Good thing I'm checking. 1 plus the square root of 5 plus 4 is equal to the square root of 3 times 5 plus 1. So this is 1 plus the square root of 9 equals the square root of 16. 1 plus 3 equals 4. 4 equals 4 checks out just fine. So that answer is extraneous. This one is good. I'll write it as a solution set. And I believe if you're careful with your steps, you have a lot of algebra involved in this. If you're careful with your steps of algebra, solving the equation should be fine.